Okay, so welcome back, and today we're going to start by giving a definition. And the definition is going to be for something called the limit of a sequence. And we're also going to define convergent and divergent sequences. So as you've seen in the last video, we saw some examples of where sequences seem to be heading towards a particular number and others that do not. So that brings up what we're going to define as convergent and divergent sequences. Okay, so in this definition it says, given a sequence a sub n, if the terms a sub n become arbitrarily close, okay, if they become arbitrarily close to a finite number L, as n becomes sufficiently large, we say that the sequence a sub n is a convergent sequence. And if it is, then we can write the limit as n approaches infinity of the nth term is equal to L. Okay. Now, if a sequence is not convergent, then we say that it is divergent. That it is a divergent sequence. Okay, now, if you look at this definition, we see things like arbitrarily close and sufficiently large. And that's okay. That gives us an idea about the behavior of what we're looking for and how we define these, but it's not very precise. So, in the next video, I'm going to give you a precise definition very similar to the epsilon delta definition that you get for the definition of a limit in general. So, but now we're going to apply a similar definition to sequences. Okay? Now, some of the sequences that we've talked about, some of those we would define as convergent. And some of those we would consider divergent. Okay, so we're going to get to that later on, but let's first go on to the precise definition. So this is a general definition, but it's not very precise. And so in the next video, I'm going to introduce you to the precise definition of when we talk about limits of sequences. See you then.